Here I have some particles and two slits. When I drop the particles, a band forms behind each slit. Now let's send the wave through two slits. There are areas where they interfere constructively and others where they interfere destructively. So when we detect the intensity, we get an interference pattern. But here's the strange part. If we shrink down to the quantum scale and fire electrons one by one, they still form that same interference pattern. Wait, if we're firing individual particles, what are they interfering with? Let's set up a detector to check which slit each particle passes through. But now, instead of an interference pattern, we just get two bands, like with the particles. So what's going on? Well, you might think of the electron as a particle, but its position is actually defined by a wave function. The higher the magnitude of the wave function at a point, the more likely we are to find the electron there when we observe it. This wave function spreads through both slits and interferes with itself, so electrons are more likely to land where the wave function interferes constructively, forming the pattern. But when we observe the electron, its wave function collapses into a narrow peak and only goes through one of the slits, so it doesn't interfere with itself. So how does the electron know it's being watched? Well, to observe something, we must interact with it, such as bouncing a photon off of it. This interaction is what ultimately causes the wave function to collapse when observed. To the electron, it's like getting hit by a ball. If I weren't there, the ball would have kept going, but I was, so its path changed. And that's what a quantum observation is, an irreversible interaction that leaves us enough information to know where the electron was. This effect doesn't just happen to electrons, it happens to atoms, and even molecules. Wait, but we're made of molecules, so why don't we act like weird quantum waves? Well, because we're constantly being observed. Air molecules bump into us. We emit photons as radiation. All of that leaves behind traces. So we're never truly isolated, and it might feel strange, but in a way, being constantly observed is really what makes us, us.